Hi everyone, good evening. So we will be doing some finalizing work on the iCEBreaker bitsy tonight. And it's just an ad hoc stream, nothing special, just finalizing what we were working on, do some polishing. There were some suggestions what to improve on the design, like small stuff that we can do. And then I wanted to generate the Gerber files, check them again, see how they look, and then place an order with Oshpark and Osh stencils to order those parts, and then also review the few extra parts that I need from LCSC that I don't have in stock because the iCEBreaker bitsy overlaps part-wise to a big degree with the full-size iCEBreaker, so we don't need any extra parts from that point. So I can use, because I'm doing assembly of the iCEBreakers here on my own machine, I don't need to order additional prototyping parts. I can just steal a few parts from the pick-and-place machine, essentially. Yeah, that's the plan for tonight. Sorry for the very late stream, not at a normal time and not really announced early, because I have a lot of stuff going on and I just wanted to squeeze this in the middle, at the moment when I can come around to do it, so that at least you can witness the ordering of the parts. Yeah. Little bit. Hi, welcome. Kano, what? Quan of Squirtles. Thank you for your follow. Welcome to the stream. Yeah. Okay, so let's look at this. So this is the LCSC order. The main thing I wanted to work on is the finalizing and the cleanup. So we should look at the to-do. I did do silkscreen cleanup per se, but I wanted to add a few more legends. So let's call it that would be one thing to do. Then the other is, I keep forgetting. You're not the first one to ask. It is something along the lines of simply to do or something like that. And I don't remember. I did post it before. I would have to check. I think that's what I looked for. Yeah, plain tasks, that's what it is. Add more legends to silkscreen. Then we need to yeah. Yeah, questions are fine. You're welcome to ask. That's why I'm live streaming this, so that people can ask questions, you know. That's fine. Yeah, I'm realizing in several positions here. It's like, for example, I was doing the pick and place assembly on the iCEBreakers, and people were asking what pick and place machine that is. And instead of just looking at the comments of the tweet, people just automatically ask. They don't even try to see if someone else asked the same question and get a reply for it. So I replied to that question like 4 times. But yeah, the point is, yeah, no, exactly. That's the idea. I need FAQs. I need more FAQs. I need more links that I can just post to people. And that's why pretty much every streamer has in the description, what gear are you using? What camera are you using? Because these questions come all the time. They're completely irrelevant to the content of the stream, but people still ask them. And so you need to have this like path to get people in that direction. On the other hand, I want to see more people do streaming about electronics. No, you're misunderstanding what where I'm getting with this. I actually find it important to share what tools I'm using, what plugins I'm using, what gear I'm using, because that might encourage people to do some streaming. That said, if you want to do some streaming about any of this kind of stuff, just take your laptop, they usually have a camera built in, install OBS and go for it. You don't need any special gear, just do KiCad Let's Plays by streaming your screen with KiCad. That's how I did a lot of streaming. And if you want to improve from the camera that you have on your laptop, get a dedicated, like a Logitech webcam like I have, or get a microphone and connect it to an external USB sound card, and. So you can slowly improve on this. One thing to be said though, the video can be complete potato. Audio has to be good, otherwise people will not hang out. It's really, that's my personal perception when I see people stream and there is a massive amount of echo and it just sounds terrible. It's much harder to stay around and listen to people with bad audio. Bad video is much easier to handle somehow. So yeah. People underestimate the audio quality. And you don't need to do much to get good audio. Get a USB microphone like the, what is it, Blue Snowball, for example. They are not super expensive and they sound great. I'm actually using the Sennheiser EW100 lapel microphone to like reject the external sounds. That works hopefully good enough for this. And it's wireless, so I can move around in my shop and I'm not tied by a wire. And I'm using it just the cheapest Amazon USB sound card to connect it with. I actually did look for a good sound card here. So it is like, what is it called? Syba, SYBA. Someone recommended that. And then bought a newer version of it and it turned out to be worse. Anyways. Tangents and rants, but important. Okay, so let's get back to it. We need to add more legends. We need to add via to connect coupling caps better. That's important. Well, welcome. Yeah, people do. There's more and more of us. I also myself discover more and more people doing this. The OG of this kind of stuff is definitely Scanline. Micah Scott, she did that. She was one of the first that I've seen doing live streams, doing electronics and hardware. Yeah. Shackler's codes, yeah, please do some FPGA streams. Yeah, apropos FPGA streams, TNT or Sylvain Manaut, he does some really good FPGA digital design streams, really good stuff. Yeah, Micah is coming back slowly from long hiatus and move and house move and stuff, so that's nice. Yeah, and then there are other people like Kate Temkin is streaming really awesome stuff. And then, yeah, there's quite a list. Oh, awesome. Yeah, thank you so much. Thank you for, yeah, everyone who buys from 1Bit2, Crowd Supply, Mauser, the iCEBreakers is definitely, yeah, I'm glad people are getting those because that helps with this and me being able to share stuff. and then building new boards and stuff. So yeah, thank you. I hope you have fun with it. That's the most important part. Ah, yes. That is on my bucket list for a while. Oh, yeah. While it is, the whole thing is anyways pretty casual, this stream. Apropos plans for iCEBreaker, I do want, so a person, it's somewhere in the forums, may already ported NES to the iCEBreaker. I think without the audio, but at least the other hardware is there. So I really want to get NES running so that I can show it off on stream. I even started buying ROMs, NES ROMs for new games on Kickstarter and whatnot to play them on the iCEBreaker. And yeah, there's so many people actually releasing NES ROMs, and so far Micro Mages I tried out. Man, what a great game! So well done. And then there's many others. There's Trophy, I think, is now on Kickstarter live. I think the last day or two, you should check it out, and so on and so forth. So I really want so what we are missing for this, we have the HDMI PMOD, but we need to make a connector that connects the game controllers for NES or SNES, probably SNES controllers in my case, as well as audio. So audio is pretty trivial. It's just GPI open and then probably amplifier, we will see. I will probably steal it from the, what is it called? One-Up. It's the previous console I made for the bitsy. The bitsy board that I made, and I will steal the audio from there. Bob Miller, or K-Bob, he made an awesome audio board for that. So I probably will take that circuit and put that on there so that we have stereo audio output and game controllers, and then we will need to do some more work to compress the current state of NES, because it's pretty big. I think without the audio, it almost fills the FPGA. In the worst case scenario, we can use two FPGAs and just make them talk to each other. That's not a problem, really. And then these iCEBreaker bitsies would be perfect. Essentially like dip chips that we can plug into a board, and one is the console itself, and the other one is the audio subsystem, for example. That would be fun. Anyways, that's it. Plans for the future. So very soon, I want to do the PMOD, at least to connect the controllers so that we can play NES. Game Boy stuff, that is totally on a bucket list. There's several Game Boy implementations in Verilog using the open tools. I am not sure what the status is running them on the UP5K, because it's not a huge chip. I know ECP5 already can run. No, there is a Game Boy implementation for Xilinx FPGAs, which are just massive monsters compared to others. Then I'm not sure it might fit on the ECP5, and I'm sure it will fit on the UP5K if you are efficient about your resources and try to compress stuff and like work on it. So I'm very excited to hear that you are interested in doing Game Boy stuff. That would be really awesome. Yeah, NES connectors. Yeah, so you can buy NES console side connectors as replacements on eBay as well as AliExpress or whatever. I have them here somewhere in a box, so we will definitely pull them out and make some footprints for KiCad and plug them in and do some awesome stuff. Yeah, we have to wait for FOSS toolchain. Yeah, it still will take a while, but it's getting there. Dave Shah is very actively working on that, on getting the Xilinx definitions into NextPNR. So if you have money left, send them his way on his Patreon. He definitely appreciates that, so that he doesn't have to take on other jobs and can focus on this. Yeah, the HDMI, no. HDMI only has video. It's actually DVI, digital video interface. And because getting an HDMI chip that has also audio encoding on it requires a license and an NDA, and it costs a bunch of money and certification, and I cannot publish the boards files for it because you need the NDA for the datasheets for those parts because of the DRM stuff. I don't know how much it is, but the licensing costs for HDMI standard and certification. Oh, yeah, great. Yeah, no, we are not doing that. So for HDMI, I think HDMI, you can, there are separate pins for the audio, and they might be an option for analog audio output. Correct me if I'm wrong, if I'm dreaming this. And we might be able to feed in some audio from the side there. If that works, why not? Otherwise, we need just a separate audio channel, and that will be on the separate PMOD. Yeah, well, we'll have to figure that out. So so we have HDMI. For now, we will just have HDMI and a separate audio output. And what I was going on for another step down the road, we can make a hat for the iCEBreaker, and then have everything combined with the HDMI and video and controllers and audio and whatnot down the road. Otherwise, we can have a carrier board and use the bitsys. There are many ways of skinning the cat here, so we will see where that goes. Okie dokes. I just had a conversation on Twitter about the ums that I'm doing a lot when I'm streaming, and I try to fight them so hard. Yeah, I still don't know how radio hosts are doing this. Add more legends on silkscreen, add via to connect the coupling caps better. Then we need to, one of the steps will be swap logo to 1B2, because in the repository I'm not uploading my logo because there are lazy people that just want to make a quick buck and make the boards, and it is good to distinguish the boards they make from mine by basically not having my logo on them. So that's one thing that we will do. Chalker's Codes, right? That's how your name is pronounced. Welcome to the stream. Thank you for your follow. Yeah, Chalkers, right? Like chalk. Yeah. All right. Thank you so much. Yeah. Good, good, good. So, swap logo for 1B2. What else? What do we need to do else? Let's look at the board. So, I think the easier thing is to actually look in 3D view what is going on here. We're pretty much done, and I did clean up some traces on the board. In between the streams, from the last stream to this one. We need to add those vias, we need to clean up things. I probably should put a copyright in or C in brackets in here to make that clear. Yeah, it would be nice to add legend to all the holes, just like on the bitsy. They're not really readable by a normal user because they're really tiny. I did add the numbers here. So that is still silkscreen related stuff. Yeah, I already swapped the logo here. I will swap it back because I want to be able to save the board. There we go. There we go. Yeah, it would be nice to actually do some more major rebuilds, for example, getting the PS RAM on the top of the board, because actually it should be possible by putting them 90 degrees to the right and then next to each other and then moving the oscillator to the other side of the board. But this is too big of a yak to shave for one stream for sure. And I do really want to order these prototypes, and this should be good enough. We did make the major changes we wanted, like adding the RGB LED and adding the PS RAM footprint. Yeah. Anything else? I guess when I think of them, I will add them to the to-do list. But for now, let's just get going. The thing that was missing was legend for these jumpers, what they are. That should be described as let's go to the page down. Do I have a good size? Yeah, let's use this font size. So this is let B. Like this. Will that fit? Should we have this rotated in some way? Trying to figure out which, oh yeah, it should be rotated just like the VCCIO02. Yeah. Then let B, let G, and let R. Meaningful information. This is KiCad, yeah. Yeah. Adding good documentation to the silkscreen is difficult indeed. That's true. It takes a long time and a lot of passes. The iCEBreaker went through what? A, B, C, D, E. So 5 revisions, and I definitely in every revision I was improving the silkscreen documentation. And the last run, thanks to Jordi, who put many hours of his ideas what I could improve. He was being like pinpoint accuracy. This has to be improved. This has to be improved. This has to be improved. This is inconsistent. Oh God, we went back and forth, back and forth. That took a while to polish the silkscreen on the iCEBreaker, the full-size one. This board is not even close to being finished in that respect. And every revision will get a little bit better. And that's good enough in my book. If we get, every time we get a little bit better. Probably want this like that. Is that better? I don't think this is better. This is too cluttery. Okay, and then we need to add a legend to this one. V1.2. This should probably be here on the side. Where is it? To V1.2 there. And this is V3V3. No, it's not. This is VCCIO01. that's what it is. Right, and then I think this is how it was on the other side, correct? So let's see how that looks. VCCIO2, VCCIO12, no, 01. I'm wrong. Hey, Jordy. When we talk of the devil, right? Yeah, no, that was a great effort. I really was happy with how much we accomplished in that intense session of tweaking the details, tweaking it. It was great. Yeah, you should make your own board for it. Yeah, the KiCad is for the whole board design. You make the schematic in a schematic editor here, and then you make the board design in the board design software. I even make the panels in KiCad, which it doesn't fully support, like not officially and not fully support at the moment, but it's possible to do with a little bit of elbow grease. It's possible. I wish there was a good internal plugin like the web, like the HTML bomb generator. But eventually, I know Wayne is considering it, but it's this like doing a good panel generator and manager is hard, and it requires a lot of functionality that KiCad currently doesn't have yet. But they know about this, and they are adding features in a way where it's like that will flow into being able to eventually do panels with it. So looking forward to that. Okay, so where was I? I managed to distract myself again. Oh, I wanted to fix this. This is not VCCIO. This is 01, which looks great. VCCOO. VCCIO01. Oh well, it is what it is, I guess. Yeah, the 0 should have, in the font, should have some indicator that it is a 0, not an O. Seriously. Yeah, unfortunately, KiCad has its own font built in for the silk screen. There are plans to support external fonts, but it's not in there yet. So many plans, not everything is implemented yet. Okay, so jumpers. Let's see which jumpers are not documented yet. This one is documented, this one is documented. We have VN jumper, we have the LED RGB. We have this, so that's good. So anything else? We could do some yak shaving on the legend of the pins, but it's not really that important at the moment, I think. I am fine with the prototype being as is. And let's look at the top side. Do we need something here? Yes, we do. Ice chip select, and this doesn't have a legend. We should at least put some effort into documenting this one. It will be tiny and probably completely unreadable, but it will be there. So let's do that. The pin is called VPP2V5. Let's squeeze it in here. 2v5. How did this also slip through? I have vocals again, and I didn't realize that it slipped through my cleaning up of the playlist. So let's deal with that really quick. It's a good song, but there we go. Yep, it's good stuff. It was I think they just released that album the other week, or at least I saw it on it being on the release or added to the newest songs on the, how are they called, on the new Retrowave label. The Look Hush Transient Off-World album got released. Okay, let's see. Come on. VPP 205. I don't like it. I think I should push it at least here to the left. It's interfering too much with the iCEBreaker bitsy stuff. Let's move it here, even though it then is it looks like it labels those capacitors too. But that's the best I can do, I guess, for... Otherwise, I would have to make a frame around it or something. Anyways, it's fine. Move. Let's do this way. It probably will be not visible because these vias will not be fully covered, and then you have holes in the text, but what do you do? I should, in the next revision, find a way of moving those jumpers to the back of the board again, especially when I move the PSRAM chip to the top again. Oh. Does KiCad have an SVG import for other artwork for the silkscreen? Does have something for that. I think there's import and then import graphics. You can import graphics, and this is DXF. At the moment, I am pretty sure there is a way of doing SVG. The SVG import is rather, as far as I saw, oh. Philip Powers, thank you for the follow. Welcome to the stream. Yeah, so there is some SVG stuff. I might be not enabled in the stable build. I think it might be enabled now in Nightly, but I'm not. The bitmap converter there. Yes, that's a. Yeah, but I think it is just a bitmap converter. Is it also SVG? Maybe it is also SVG. The problem I saw in the algorithm that they were using, they were converting all arcs to straight lines at the moment. They don't do, what they could do is approximate with lines and arcs to decrease the amount of segments, but they don't do that algorithm yet. And I really wish they improved on that to actually use arcs too. Although all the arcs, oh, thank you for the subscription with Twitch Prime. Thank you so much. I really appreciate that. Yeah, so they do they do convert everything to straight lines. Even now, even circles and cutouts are made out of segments, which is pretty weird because Gerber files do support arcs for apertures. So they could use arcs that are then being understood by the PCB manufacturer. But KiCad basically, in general, converts everything to line segments. And it's a little bit weird to me, but it might be some legacy thing, there might be some technical limitations, I don't know. It's probably boils down to still not enough developer time available to make these things better. But they are getting better. Just remember, they are always getting better with KiCad. The movement is really good, in good direction. Okay, I keep repeating myself every time because we are getting new people here, which is nice. Okay, let's do this. Let's look what else we need to improve on here. So we have just the VPP 2v5 jumper legend. We do have the RGB, we have the user button, which is essentially the boot button, which is fine. Then we have these signals documented. These are not documented. I ran out of space because the CDAN wasn't, I didn't have space because the CDAN was here. So maybe I can at least add and say that this is DI-DO D2, D3 maybe. Yeah, this shouldn't be. This is not very readable. I'm not super happy with this. I have to come up with a better solution in the next revision. This would be a 2. So not the PCBs. I do order the PCBs, but I do assemble the boards at home. Yes. Depends on the quantity, though. I am trying, one of the resolutions for this year that I made is to push more of the manufacturing out to contract manufacturers this year. So that's something that will be happening, because I should be spending more time designing hardware and less time making hardware. It's promised Kate to ask me, it's like, you have to decrease the amount you're spending on this time-wise. And I was like, yes, Kate, thanks, Mom. Oh, come on. There. That's better. You don't need this. This looks weird. Come on. Oh. Not track. Why is it not selecting this? Come on. Let me select you. Oh, come on. What's happening here? Whatever, it's good enough, I guess. Even though I would like to maybe push it to the right here. That would be nice. Yeah, like this. There we go. That worked. There we go. Yeah, it's not perfect, but it's good enough for now. Yeah, our pick and place hard to set up. Not really if you get a proper machine, but if you ask people, let me if you ask people like Unexpected Maker, who bought one of those cheapo Chinese machines, it took him 6 months, or no, 3 months to get the machine for one board tuned up well enough that he can run it at a full speed of the machine that it on paper can do. And changing over to any other board will completely destroy the calibration, so he's stuck essentially with one board that he can assemble. But the machine costs what, $4,000 versus $30,000? So yeah, that's the difference with actual industrial machinery and what boils down to a toy that people buy to do maybe some prototypes at a very low speed. But it's not a machine you can really consider using for manufacturing unless you're crazy like him. Yeah, I have big respect for his dedication to keep doing that. But he did a lot of boards that way. The silkscreen business on a huge board like the bitsy looks like horologist work. Yeah, it's like carving. Yeah, Mr. Horologist, I found him only a few days ago on Twitch. He has a very nice, he streams every day and he works on watches and does servicing. It's just beautiful stuff. I really enjoy that. So check him out if you're interested. Yeah, thank you. But yeah, in my case, it is so much simpler because, oh, I can clean this up. I don't need this kinks in here, do I? Oh, I couldn't completely get rid of it. That's what was the problem, because the via would go a little bit too deep. Yeah, I can do this. Okay. Yeah, horology, a lost art that is being rediscovered, I think. So many watchmakers were out there servicing watches. That art, they almost died until people thought, oh, this is actually pretty cool. And there are some really amazing artisans that are doing this. Yeah. D3, D2, that should be good enough. Now it says 2D and 3D here. Yeah, it's not great. Yeah, I think this is good enough. I did clean up some things. Okay, so let's check that off the list here. For now, and then we should add those vias here. So what is the problem that we are trying to address? Oh God, I already have the feeling what has to happen here and I don't like it. I would need to do a lot of swap de roue here. So essentially, George Locamides and Sylvain, they pointed out that these parts here, which are the decoupling capacitors, they are not properly connected to ground at least. So that's already bad. But the other problem that we are having is that if you want really good coupling of the decoupling capacitors to the power supply, you want to have via, so one for ground, one for power, and then that be connected to the power pin of the chip. That is the cleanest solution if you can make that happen in the space constraint that is here. And now that I look at this, if I wanted to fix those VCCs, I will have to reorganize all those vias and completely swap it back, forth, back, forth, back, forth, and reroute all this stuff here. What I can definitely do, so if I disable the inner layers, which is here the power layer and the ground layer. Thank you for the follow. Very long name. A fake chicken robot. Now I can parse it. It took me a little bit. Thank you. Thank you for the follow. Welcome to the stream. Yeah, so we can definitely add the vias to connect to ground. So that's definitely doable. Maybe not for each decoupling capacitor, but we can add a few. What we would have to do for the power is swapping things back and forth. Yeah, well, that's a BGA, and like that has a huge bucket full of decoupling capacitors on the back of the board. So yeah, you have my deep condolences, I guess. Yeah, I'm sorry. That's a pain in the butt. Okay, so let's add these. We can add these and then add one here. I think that would be good enough. I wish I could add a third one. Maybe we can at least do this, make some space, and then put one here, right? So that should be already helpful. Is that far enough? Why did I disable grid? I think I disabled the grid. View, show grid. Oh yeah, that was the problem. This is 1, 2, that should be fine. 1, 2, that should be fine. And then we can run this guy. That should be fine. Oh, it will collide here, I'm pretty sure. Huh, it's actually not complaining. Interesting. I still want to move this one. Makes me more comfortable. Okay. What is your problem? Oh, it is actually that. It is actually complaining. The arrow up there is actually the problem, I think. Yep. No. No. No, it's not. Too close to via. Track too close to via. Which track? IOB 8A, IOB 8A to ground. Yeah. So it is this one. It's still too close? Maybe it is still too close. Run DRC. Yeah, okay, that's fine. Yeah, these are, we already acknowledged these. All right, so that's fixed. This is the problem of leaving a lot of warning errors that you acknowledge in such way without having a good way of marking them as okay permanently, is that you have warnings and errors that are being drowned in the flood of errors that you consider as being just false positives. That is a little bit of a problem. How can you tell KiCad to do a never done 2 layers? Yeah, there is, I think it is this one. Yeah, so select copper layer pair, and you can select which 2 layers to connect together. So this is when you would be doing blind and buried vias. We are not doing that here. They are all going all the way through the PCB. If you want them to connect to a certain floodplane or like the fill, then you can edit this. There is some heuristics that it automatically does to connect the placed vias using this tool here automatically. But if that's wrong, you can go in here and then select a different signal to connect them to. But if you are doing blind and buried vias, you would be going in here and then selecting a layer pair to place a via that is connecting and not going all the way through the PCB. Yep. Good, good, good. So this is this one side for the decoupling cups. Decoupling caps. And then we want to do the coupling caps here. We can definitely place one here, like this. And then we should probably place one here, like this. This is a bit too close for my comfort. And we should deal with these guys. Page up. Like that. There's a ground here already. That's good. And we should place one here. What's your problem? Okay, so let's do DRC again. Yeah, this is too close, I guess. Let's do that again. Okay. Oh, this error is actually has nothing to do with this is courtyard violation. So let's go through the errors again. Via too close to copper item, that's fine because this is a VN pad, which we discussed. Courtyard. We are fine with the courtyard violations here. I probably should find a better way of doing this so that the courtyard violations are not as problematic. I think when we do the next revision, we will go to the DFN voltage regulators, which are smaller. Then we will make more space, and probably we will not have to do this horrible stuff with the courtyards. And then it should be better. Humans are amazing, yeah, sure. I'm not sure in this case what you mean, but yeah. Okay, so that's cool. So we have additional vias. I hope George and Sylvain will approve. I think this is better actually. Feels a little bit better to get it further closer to here. Yeah, thanks. Yeah, it's fun. It's an alternative to Tetris playing, I guess. It's just a game at the end. Humans like games. And I like games too. And this is essentially that. via. Okay, close. Good. I should delete this again. All right. Okie dokie. Oh, I should add a via here probably. Yes, for sure. Not too close to that trace though. That should do it. Any more grounds that I need to add? Ground. Oh yeah, it would be good to add one here. I do have this one, which connects to this. I don't really have space here though. Maybe if I go on the bottom layer and shove this stuff out of the way a little bit, we can get some more space. But I'm not sure it is really worth it. Let's do this. Like this. Stop it. Don't go crazy, please. There we go. Will that be big enough to make space there? Nah. It's not worth it. Nee, das macht man nicht. Okay, cool. I think it would be nice to actually clean this one up if I can. Ugh, what is going on here? Why is it so crazy? Ooh, there's some like this. Yeah, the problem, yeah, that was the problem last time. It was going a little bit nuts. Yeah, let's leave that this way. It's fine. This is completely being OCD at 100% here. It's not really necessary cleanups. Okay, cool. So far, so good. Any other decoupling capacitors that need their own vias added? We have this connected pretty well. Let's look at the flooding. Page up. Flooding is good. We have this ground here, which is interesting. Oh, what? Let's add one here then. That should be better. Oh, it might be related to the inner layers. Let's see. So this is ground, and this is the shield floodplain on the inner layer. And then we have power. Oh no, that does look fine. And the ground and power, what? Oh, because it wasn't rebuilt. Okay, now it makes sense. Okay, 5 volts, that looks good. Shield, 3v3, power. I think that looks good. We have some VCCIO connecting here. Why is this so? I could have it more up. Let the flood connect. Yeah, there we go. That's better. Let's make the flood go. Something like that. To not have those whiskers come out here. Yeah, basically another massive step that I should go through eventually is cut off all those whiskers that come out, all those antennas that are not really functional connectivity for the power, and get rid of them. Maybe not in inner layers because of lamination thickness, but definitely on the top layer I should do that eventually before production, like cut off this antenna here, cut off this tusk, cut off this whole thing for no reason. Yeah. Or like a completely useless flat plane in here. Yeah, there is something to be said for not having ground fill on the top layer at all in this case, because it is so cut off, and then just only fill it in the areas that make sense. So there's something to be said to that. I probably will do that in the future revision. It's something to add on the future to-do list. Yeah, that is looking good otherwise. Any more? Let's do one more pass for capacitors. The shield. Oh, we should. Oh, this is connected to a big ground here, so that's not a big problem. Shield ground. This is connected directly to ground. That's good. This is connected to ground here. That's good. Ground, ground, ground. Where are these connected? Yeah, this is probably the best I can do. Have this connection and this connection and this connection. I could probably push this out and plop a via there. Maybe. Maybe. Oh, that's the startup capacitors. Okay, good. So let's try this. 5 volts. The 5 volts should probably get its own via, shouldn't it? No, I can't because there's this guy. Oh, yeah, forget it. I can't put a ground in here. It's fine. Forget it. It's not happening. Yeah, the 3v3 needs its vias. Should be good enough. All right. Pump. Ah, right. I wanted one here. And I think I'd added this, but I might have undone it for some reason. I think I did do that. Okay, there's no error here. Okay, cool. So let's save this. Ground is connected here, that's good. Yeah, I think we're done with the, the coupling capacitors. Good night, Cano Squirtles. Sleep well. Good night. Okay. So that's done, and the last thing will be one more view on 3D. How is it looking? It's looking good. Handsome, handsome. Okay. Nice. Okay. So let's change the logo. I think that's the last thing to do, unless I'm probably missing something that I could clean up. But anything else seems a little bit going overboard with the next step of prototype for the 1.0. I am pretty sure we will be doing something even more intricate. So change footprint and then change that, apply, close, and then edit. So that's something I will not be pushing, but I need it for my Gerber files. Come on. That's looking good. I probably could put a bigger one in here. Let's see how that looks actually. This 6.5. Oh, that does almost fit if I scoot it down a smidge. Yes, move. And then, come on. Something along these lines, yeah? Nope, wrong direction. Let's see. Yeah, that looks fine. Sweet. I think we are happy. Or I am happy. I think that's good enough. Okay, so let's save that. All right, so one thing I have to make sure is what are my preferences? No, board settings. Let's make sure the board settings are correct. Design rules. No. Mask clearance is 0.05. That should be fine. Solder paste ratio clearance 0, which is fine. Yeah, it's very dangerous. This default setting of the solder mask clearance is really high, like 2.25 or something. By default keycaps, you have to change this. Otherwise, you are in the world of sadness. Okay, cool. That should do it. Now let's plot it. Front copper, copper, paste, silk, mask. Edge cuts, that's all we need. Protel is fine. And the Gerber directory. Okay, let's plot this. And we are using, where is the setting? Where are the metric settings? Coordinate format, unit, millimeters. It's late and my brain is a little bit fuzzy already. It's better to stream earlier in the day. Yeah, no, I think it's fine. I'm still not seeing a secondary setting for this. Footprint, exclude pads, do not tend VS with no, definitely not. Use auxiliary axis as origin. Yeah, it's fine. Okay, we plotted this. All the layers are enabled again. So this is, I have on the fab layer, I have the legend of what the pins are, just for reference purposes. Okay, so now we can go, let's make a Gerber directory. So iCEBreaker bitsy v03a gerber, copy everything, iCEBreaker bitsy what? Oh, this is the to-do. Okay, fine. And then gerb let's try that. That should, oh, they changed it. You cannot have, it doesn't, gerb was falling through if it didn't find some files. And now it is failing. I would hope that there is an option for that. Because I do have layers enabled in my preview that I sometimes don't have available. So let's just remove the fab layers. That's annoying. I feel it should just fall through. They definitely changed that. bpaste? Wait, what? bpaste GBP? No, oh, DRL? Oh, drill file. Oh, I'm so stupid. Okay, that's just being dumb. Generate drill files. Yes, please. Generate drill file. Close. Okay, that was stupid. There we go. Oh, okay, that's better. All right, so that's the Gerber files. I like using gerb instead of using the KiCad Gerber previewer. I like using some code base that is from a different project. This way, it's like multiple implementations with multiple safety levels by having a different group of people write the parser than the people that wrote the generator is a good way of improving the probability that we get it right. That's why I use gerb instead of the KiCad viewer. This is from the GIDA PCB project. Also, I like their viewer better than the KiCad one somehow. It's nicer. Okay. This is looking good, and a very good way of seeing things if something is wrong is by blinking the layer that you're looking at. That's looking good. So this is the solder paste. Solder paste is not on the jumpers, which is exactly what we want. And it's not on the through holes, it's only on the copper that we want. I think it looks good overall. So off, then we have the outline, we leave that on. We have the drills, we leave those on. Then we have silkscreen. That's looking good too. User button, looking good. Then we have the solder stop, which is the opening in the paint on top to present the copper for soldering. There we go, that looks good. It should be slightly bigger than the pads. That's the important thing. We can also do high quality, then it will take forever to render, but then it looks so nice and fancy with the transparencies. But yeah, that's not really necessary. Or XOR is also a way of seeing differences. Normal is this, which also has some transparency, but is also a bit slow. So I use the fast one. Okay. Yeah, that's looking good. Then the top copper. Yeah, yes. The top copper, and it, wow, there's none of the signals are actually connected on top, like almost none. Wow. Everything is on the bottom. So we break it out on the bottom. That's interesting. I didn't even notice that before. Okay, so that's the ground plane. Ground, ground, ground. Then we have power. That's power. Power. Okay, cool. And then we have the ground, or the back side, which has a lot of the connections. Looking nice. This should be smaller than the openings from this side, because we are looking through the top. No, I will not do panelization for this board. These are just prototypes. I do panelization for boards that I do assembly of, so closer to a full production run. We will get there eventually, but it's not ready yet. This board is not there yet. I do have to do some panelization of the HDMI PMODs, or no, HyperRAM. What am I talking about? The HyperRAM memory PMODs. I need to panelize those, so we will probably do a short stream doing that in the near future. Okay, so that looks good. And then we have the silk screen on the bottom, and then we have the solder on the back, which is the user placeable part. This is the only part on the back. And I think we will flip it up and on the top of the board in one of the next revisions. So I think the 1.0 or the 0.4 will be quite a big rework because we have to move a lot of stuff around. But the circuit will be the same, probably. So yeah, cool. That's looking good. So if that's good, so zip -r, iCEBreaker zip, and then iCEBreaker bitsy version 3a gerber. Now we have a zip file, and that's number 1. Then we have to also make stencil gerber, because we will need stencils to populate the top. And then edge cuts. Uh, 0.3. Oh, come on. Bitsy V. There we go. A stencil 1, and then we need the top paste. Top paste. Okay, so now we have also this. Stencil gerber, then zip. Get out of the way. Bitsy version 3, stencil gerber. Oh man, God, I'm really getting tired here. It's a long day. All right, pack that. So that's good. I want to move this back where it was for the future. Okay, so that's that. Now we can actually submit this. So let's submit this to iCEBreaker. So to submit this to iCEBreaker, I'm logged in into my account and then can either drag it in here or browse files. Project iCEBreaker, iCEBreaker hardware, and then we need the zip file for the Gerber files that we'll be uploading to iCEBreaker. What was the message on the top there that I didn't read? As of April 3rd, we are still operating normally. That's good. So, iCEBreaker bitsy version. So let's just rename this nicer. So if you need some prototypes of PCBs, make sure to go to the good friends from iCEBreaker. They deserve your business. Anyways, go. 4-layer board. That looks good. As KiCad zip file. Oh, it does detect that it was made by KiCad. Interesting. So that looks good. I usually like to save all the images that it generates. Then I can post it on Twitter. And then also for my future reference, you don't get access to all the generated files easily if you don't save them yourself later. You only get the full renders. And I like having them as reference to see what, if something goes wrong, to see what happened and where the issue is from. If it was my files, or if there's some issue with the Gerber processor on iCEBreaker, which I didn't have yet, but it's good to have that ruled out. We're almost there. What? No, it's not what I meant to do. All right, saved. Now let's order it. Okay, we definitely want more than just 3, because 3 is very little even for prototypes, and I am pretty confident these boards will work out fine. Yeah, how many should we get? 6 or 9? Let's go for 9. Let's be... All right, that looks good. 31 bucks. That's very reasonable. I don't need a teensy, sorry. Sorry. Paul, if you are in there in the chat, because Paul was joining the streams in the last few days. But if you need a teensy, you can get it here. So that's very nice. Okay, I think we are good. Let's check it out. Check out. I hope I didn't miss anything. Yeah. Okay, we don't need my street name and whatnot. I will finalize it and make the payment later. Yes, it's very similar. It is definitely inspired by the footprint. So if you look at this, so this is a teensy. So let's see. So this is a teensy. And this is the bitsy. So the bitsy has one additional row of pins here. That's the only real difference. Let's see if we can get closer by here, and it will still focus. Yeah, there we go. So yeah. So this is the lower one is the teensy, and the upper one is the bitsy. And yeah, they are definitely inspired by each other. I had to add additional row of pins though, because I really didn't have enough. I had more pins that I needed to break out. So yeah, that's the only difference. So it is not perfect, but it's definitely inspired. Squeak, squeak, squeak. They should do something. There has to be a way of having that arm be less squeaky when you adjust it. Yeah. Okay, so let's order the this stencil. So upload design, and we don't need the black magic probe. We need the where's the iCEBreaker? iCEBreaker hardware, bitsy, and stencil gerber. So OSH stencils, I can directly order. So there is an integration in OSHpark to use generate the necessary gerbers and go to OSH stencils directly. The problem with that is it is, I think, using the copper directly to generate the stencils, I think. Because when I was comparing it, it was not what I wanted. I actually want to use the paste layer Gerber files directly myself that I upload. So I am not using the integration that is on OSHpark to OSH stencils, but go to OSH stencils directly. Fun fact, these are two separate companies. They have nothing to do with each other. They are just very friendly and they work together. And they have similar names. But these are two separate groups of people running both stores. So just as a side note. Not that it really matters. They are both very good companies, in my opinion. Has been uploaded. Okay. And now I need to... Edge cuts is the board outline. And the top stencil is top stencil. That is correct. I don't need the bottom stencil because that's completely hand solderable, especially for prototypes. Ah, Sylvain, good morning. No, not Sylvain. Drew, good morning. Hi, Drew. I am tired. I'm mixing people already. Yeah, so I already placed an order with OSHpark. It's already placed. I just need to make the payment. So that's already done. And the board is finished, yeah. So I did some additional cleanup. I added some vias to connect the decoupling capacitors correctly, and added some silkscreen, just minute polish. And I am happy with it. And now I uploaded it to OSHpark. I already placed that order. I just have to make the payment. I will do that off stream. There's like my address and whatnot. It doesn't need to be on stream, right? And yeah, and now I'm uploaded the file. So I am not using the integration from OSHpark because, as far as I understand, correct me if I'm wrong, OSHpark sends like some type of pads from the copper layer instead of using paste Gerber files that are uploaded to OSHpark to generate the OSH stencil order. Because the last time I tried that, it didn't generate the stencil the way I wanted it to. It was weird. Anyways, it is there. That's nice. But it didn't behave the way I wanted, and that's why I'm uploading my paste file, Gerber file, directly to OSH stencils instead. So yeah. No, just the Gerbers. I uploaded Protel Gerbers. So my settings for Gerber files, just for reference, are like this. So you can hopefully make a screenshot of this. So that's one. And then drill files is this one. That's the dialog for drill files. Not that, drill files are irrelevant for you, so I know. But yeah, and then I have the fpaste and bpaste that I'm uploading. And then after uploading this, I think what happened is actually it was using pad information from the copper layer instead of the paste files. Yeah, it was, and not edge cuts, but the boundary or something. It was, as I said, it was slightly weird. It might be fixed already. So yeah, talk to Dan. I'm sure Dan will quickly give us an answer. Okay, top stencil is fine. Now what I like to do is actually rename that project name. The project names are auto-generated. Like something short, iCEBreaker, and then version is 303A. Let's do that, create project, and then I can select it here to have it a little bit more concise in the menu later. So generate stencils. It's now generating the stencils. There we go. And what I like to do, so it already took my defaults, but I use the default thickness, and even for prototypes, I don't bother with Kapton stencils. I always get the stainless steel stencils from Osh Stencil. It is more expensive, but I feel it is not worth my time and trouble when the Kapton stencils work. They're fine. They're cheap, but they don't give you as much of a quality as than the stainless steel ones, so I rather get the stainless steel ones. And now the important thing is, let's call it iCEBreaker version 03A, so that it gets engraved on top of the design. Save settings. Then it should pop up here in the right corner. Yeah, there we go. So they will engrave that so that we can see it. Okay, cool. Add stencil to cart. Then we already have it here. 16 bucks. It's not end of the world. And we can also add acrylic jig set. I use the acrylic jig sets a lot, and I keep ordering more and more of them. I have probably quite a collection by now, but yeah, I see there are a bunch of free ones sitting around here now, so I don't think I will be ordering them this time. And then I will continue through here, make my payment, and place the order. But as I said, I will do that off stream. There is no need for that. Yeah, and the third thing that I will have to place an order for are the remaining parts. So these are the 3 parts that we will be ordering, because I don't have them as part of my already existing iCEBreaker. So this will be the oscillators, the RAM chips that go on the back of the board, and the RGB LEDs. Oh, there's like still this guy in there. I think I removed it from the cart. There's no need for it in this order. Yeah, there we go. So just these 3 parts. The side note to that, if I was making a full process of ordering boards, and I didn't know exactly which parts I need, the thing I do is actually go into the schematic, use the table view, and I created a custom field which is called key. And these are my internal keys that I use for parts in my own bill of material management, which is essentially a spreadsheet on Google Docs. And this is how I referenced different parts so that I have a consistent system for referring to parts. And then I would make sure, for example, the RGB LED doesn't have an ID yet. And then the RAM chip I don't think has, yeah, so this would be called RAM or PSRAM. I don't have RAM chips yet in my collection. I think there's HyperRAM now. So PSRAM, and then probably in this case just the just SO8 as a package size, and then Li6864, because it's not a generic part, it's a specific part we are getting here. If it is a generic part like a voltage regulator, I have these generic names for them. And this would go then into my spreadsheet, and then I would make sure that I have all the parts and then mark them as selected, ordered, not ordered, and on the way, blah, blah, blah. So there is a separate system for that I built for myself. Yeah, so here, for example, this LED, this tri-LED needs to have also a name. So this is LED 1010 RGB, essentially. So that's the name we need, because this is the size of the part and then what the color is. So in this case, it's RGB. Apply to schematics and continue, then it will transfer those fields. And when I'm done with assigning those names, I can go into the BOM generator, and I have this TSV generator script that I adapted. So this is BOM to TSV XSL file. This is like a template that you can use with the XSLT proc to generate bill of materials. So yeah, I have them for TSV, grouped TSV, grouped CSV. So the difference between grouped and not grouped is if you have them grouped by part type, or if you have just the IDs or just ordered by IDs, then you have like 50 lines in that CSV which say it's like, this is 10 microfarad capacitor with the on the field so and so and so on. It's like each line. And the grouped ones, it's like it's collapsing the same type of part and saying this type of part, so many placements on these footprints, and that's what I usually generate. So group TSV. Yeah, so if I generate this, we can actually open that in Sublime, for example. Let's see, iCEBreaker, bitsy. Did it do the GR in here? Wait a second. Is it adding the GR? Oh, grouped BOM. Yeah, close. Yes. So yeah, that's how it looks, and then you can load it into a spreadsheet and work with it. Yeah, so that's that. I think this is everything that I wanted to share for tonight. I will order these parts. They will arrive sometime in the future. And Oshpark probably, what, 2 weeks-ish, because I'm also in Oregon. So they will order the boards. They take about a week, or used to take about a week. Probably now, who knows how long this will take because of the situation in the world. But then they will come here. So they come to Oregon, they break them out, and then send it. And because I'm also in Oregon, it just takes 2 days from them to me to arrive. Oh, same schedule. Okay, good to know. Thanks, Drew. So this is basically about a week and a half-ish that it takes. Okay, cool. Good to know. Yeah, so if you like what Oshpark does, place orders with them, because they need the business direly at this moment. So let's make some more boards. Yeah, that would be it. If you have any questions, let me know. I will post this on on Twitter that we finished this project. Yeah, I don't know if it makes much sense to actually archive this stream because it's such an ad hoc thing, but probably there's some useful stuff in here. Yeah, anyways, thank you very much for being here. Thank you everyone who is supporting this. Thank you for placing orders with 1bit² and Oshpark and everyone. Oh, Hellcat Abarella, thank you very much for the follow. Welcome. At the very last moment of the stream. Yeah, so thank you very much everyone that supports this. I hope these streams are useful to people. I hope that they are. Yeah, I will definitely stream more, and probably I might do another ad hoc stream tomorrow, doing some chill out wire harness prototyping stuff, which will be very slow and boring probably because I will be crimping the wires for an hour and a half. But it might be fun to just hang out. And yeah, support us on Patreon, and there's a link below. This really helps with making these streams possible and paying for the hardware and whatnot. It's like, but if you don't have money, don't worry about it. We are happy to share the knowledge. And but I have to say thank you to some of the generous Patreons that deserve a shout out. Thank you very much to Edward Borden, to Jordi Parky Rodriguez, Sid Price, Kelly, Tom Keddy, Drew Fustini, and Joe Go Jimmy Pie. Thank you very much, everyone. And I hope you have a good night, and see you soon. And have a good one. Stay safe, stay healthy, stay socially separated, and see you soon. Bye.